Starting off on the globe Earth to remind people that we're on a globe. Let's remember where all the gravity's pulling to the center of the Earth, that amazing gravity. And we happen to set up a little test with a vacuum chamber. Okay. We've got a vacuum chamber, and inside that vacuum chamber is a smaller box, if you will, with a sealed top, and we have air in that as well. So we've got a vacuum chamber. It's got a vacuum, or it's got air right now inside of it, and so does the box sitting at the bottom. You'll see we'll pop open the front of this, and you will see the box inside of it. Let's go 3D modeler. All right, there you go. You've got basically air inside this box and the box inside of it. Only this box inside we've got sealed. So right here we've got a sealed top. We've got air floating about in here, and we are going to go ahead and start the vacuum here in a second and suck the air out of our vacuum chamber. Remember, the vacuum chamber is on Earth. Okay? It's not in space. It's not anywhere. It's on the ball Earth. And we suck out the air from the chamber. There goes the air. And we'll notice that this box remains sealed because there's still air in this box. Okay? And then we get all the stuff out of there. Get out of there. Now, we can see inside the small box, we have the molecules of air, and we electronically peel open the box. Now, we know one of two things will happen. Either A, these gas particles will enter into the vacuum and disperse amongst the vacuum. Why? Well, because high pressure goes to low pressure, and because that's the way life works. Or will this box of air stay down because of the pull of gravity? Okay. Now, nobody would answer anything other than, of course, what do we think happens? The gas will fill that space. Okay. The gas will disperse into the vacuum, not that long and right after, but there you go. The gas will take out of the box and become part of this vacuated system. Now, that alone disproves their entire model. Okay, this one experiment, this one thought experiment, if you will, disproves it because they tell us that the reason that the atmosphere stays attached to the Earth and doesn't go off into space is because of gravity. So if gravity is strong enough to hold the entirety of the atmosphere, everybody think of wherever you're at right now, think that there's a column above your head of a tremendous amount of atmosphere that goes all the way up to 50,000, 60,000, 70,000 feet or more as it disperses and gets less and less and less until it hits the vacuum. But gravity, they tell us, is holding that air to the Earth. So if that were true, then gravity would hold the air in this little box to the Earth. End of story, period. And they can't say, oh, but Jaren, it's a gradient up to the vacuum of space. Okay. Well, then the things that are closest to the vacuum would go into the vacuum and the vacuum would lower itself. Do you understand? It's not like the vacuum is up there and then the Earth is separate from it. It exists in the vacuum. There is no barrier on the globe Earth. If you've got no barrier, what are you going to do? What are you going to do? So if let's say that here's space and it's a gradient. So there's a lot of air and a little less. Okay, well, the less is going to become part of the vacuum. The vacuum's going to lower. And then this air goes into the vacuum and it lowers. And then this and then it lowers. And then it would eat up all the atmosphere of Earth until the vacuum hit the surface. They say that doesn't happen. Why? Because the gravity of the Earth is pulling the atmosphere down, holding it down. Well, if it can hold thousands and millions and billions of pounds of atmosphere, how come it can't hold this little box of air? How come the air, and somebody might say, oh, well, Jaren, but it's right next to the vacuum here. That's why it went into there. It's right next to it. There's no, yeah, okay, so you're missing my point. So then imagine this is the very loose air molecules at the very top. Then the vacuum would become that. See what I'm saying? And it would keep lowering until the vacuum engulfed the entire, think of what they tell us the space is. It's unlimited. It's eternal. It's infinite. So think of now I know they say, well, Jaren, that the vacuum doesn't suck. Okay. We don't need it to suck. What it does is if there's any pressure near it, it basically eats up that pressure because it's an eternal disbursement platform to spread that gas in every direction possible. So the only thing that they have is saying that gravity, which only pulls towards the Earth or towards large bodies, supposedly, then explain to me why, in this case, it would not be able to hold on to that box of air. And that's basically it. It's an easy to explain issue. And I think that it's one that if you need to, talk about something to somebody, that would probably be a good start, or a good place to start their journey of thinking about things. Because again, I have not heard anybody come up with an answer. I'm going to check the chat real quick. I just want to see if anybody has an answer to this. I just check the recent chat, see if anybody, there's heavy gases that would stay in and down. There's heavy gases that would stay in and down next to a vacuum. I don't think you understand high pressure and low pressure, my friend. Think about what you're saying. Yeah, there is heavy gases, but you're talking about the vacuum right there. So you think that something like, what's the sulfaflexahoride? Hexafluoride, yeah. I do not think you're correct. Anybody who wants to back that up and say, no, he is correct, Jaren, that heavy gases would stay in there even though the vacuum's there. No, that's not the way it works. Earth is inside the brain. Our consciousness is creating Earth. It's not outside your body. Everything is happening inside the brain. It's called collective consciousness. Let's see if there's anybody else down here. My Glober friend sent me a bunch of proof. Yeah, Professor Dave, he's down. He knows everything. Gas goes in all directions. There are gases heavier than air, but gas goes in all directions. Right, especially if next to a vacuum. If you stop the vacuum pull, why would air not get back in? Oh, you're talking about in my box? Yeah, in the box. Okay, so if that's what you're saying, in the box, you're going to have all that air inside now. It's no longer a vacuum. Now it's a box of air, right? So what does that mean? I'm saying, think of that little small section as what we're dealing with in whole. You're saying, oh, no. That air would just settle back down inside that system. Yes, well, because there's a lid on it and there's sides, right? So in that system, that would happen over time, but there's no more vacuum. So if we then put that box inside of another box that was evacuated, then we open the top of that. Do you understand that the air would go into the vacuum and it would become a bigger box?